would like to acknowledge my co-authors. They include DAFWA team, Bayer Syngenta, University of South Australia, and our collaborators also from South Australia Research and Development Institute. And the funding came from GRDC, Bayer and Syngenta. So what I want to do briefly is outline what it is and where it is, just to give you an overview and some current information related to where we currently find the disease, and then go into the new findings. With rotation, you can use canola to manage disease level, and then the second component, the fungicides, the new actives that can be put into the ground using in-furrow methodologies. With all root diseases, you need to know what you had in the previous year to be able to do something in this current year, which makes it very difficult. You can't just go out and spray like you can for foliar diseases. Most of you probably would know what it looks like. It's a root pathogen. It compromises the roots, and then you get these patches occurring because firstly, the plant is compromised to take up water and also nutrients. In barley, wheat and oats, they all look very similar, although barley is more susceptible than all of them, and then wheat and oats are in susceptibility order, oats being least susceptible of the three. Varieties you can't use because they are all susceptible to the disease. Just an important point to make is patches can be caused by a number of different things, including physiological, but also root lesion nematodes. So it's important that you do know what you've got. How do you do that? You need to look at your roots. Dig up a plant and have a look. Rhizoctonia has classic spear tip symptoms. As you can see here on the red arrows, they're quite distinct. It's no use to use these management options that I'm going to talk to you about, and you've got root lesion nematodes, because that instigates a whole different management system. So know what you've got, and then if you've got rhizo, this is what you do. This is just an updated map from the predictor bee samples that were sent in from growers' fields in this current season. What it shows you are the locations where we are having different levels of detection. So the transparent ones are the below detection, the orange and red are the medium to high risk levels of detection as of 17th of February 2015. The bigger the pie chart is, the more samples that were sent in. And in fact, 54 of the 123 samples that have been sent in so far are in the medium to high risk level. So it's quite an alarming figure. That's roughly about 45%. Last year it was 37%. We had 300 samples to that 37%, so it may still go down, I don't know, but it's looking pretty dire for this season. DAFWA has been running a focus paddock project funded through GRDC, where we monitored 184 paddocks over those 5 years. And I just want to show you now what we found in the predictor bee samples that were taken in those 5 years from the 184 paddocks. So looking at from 2010 to 2014, what is quite striking is the blue portion is declining. The blue portion is the below detection level of Rhizoctonia. And then the other thing you can see is the increase in the orange and red components, which are the moderate to high levels of Rhizoctonia. So that's been increasing in those 184 paddocks from the same locations, okay? They are georeferenced, it's the same location visited over the 5 years. Now I want to tell you about rotation. You can use canola to have an effect on the disease. Going back again to these focus paddocks, over these 5 years we found only one crop that had an effect in reducing the inoculum level when you're comparing the early sample with the late in the season soil sample. And that crop was canola. And here what I'm showing you is the 2012 and 2013, and comparing beginning and end of season for the 2 years. And you can see canola in this instance is the only one that's dropping the inoculum levels. To back that up, we had a trial at Katanning. Okay, it's quite a busy slide, but I think it shows very nicely the effect it has on the following year, because not only does it reduce inoculum, but it also translates over to the following year. So in 2011, I had these plots in there. I had barley, wheat, canola, and fallow. That's your growing season here. Then I moved over to 2012. Everything went into barley, okay? And on this axis, we've got the DNA levels, which I've broken up so it's very easy to see the risk categories or the levels. So that's below detection level, low, medium, high. So it's easy to see where they sit in relation to the timing when the samples are taken. So the first point there is beginning of the season prior to sowing, and roughly they sit all in the low level. And what you can see when you move up to the sort of end of anthesis sample, the cereals increase. Barley in particular is higher, it goes up to the high level, wheat into the medium. Now the canola and fallow both are going down. That's the important point, so I'm just showing you that same, I guess, effect that I just showed with the focus paddock. But when you look over summer, autumn, the inoculum is going down, but for barley it still sits up fairly high in that period compared to canola, and wheat even goes down to quite low levels too in this case. They are significant. And then when we take it through to the barley, that is translated to a lower level in the canola and fallow plots. And that's, again, significantly lower than the barley plots. So it's having an effect in the following year. Okay, so inoculum level is impacted. Does it do anything to disease? Because that's probably the important part too. Yes, the answer is yes. Certainly when we looked at the roots, you can see a significant lower root disease in the canola plots. So this is looking at roots of barley. Okay, so in 2012 we pulled up the barley plants and looked at the roots and looked in relation to the treatment from 2011. So that was significant compared to the barley. Fallow I was anticipating also, but we did have some wheat issues there, so I suspect that is why it's sitting in with the wheat, but I would expect it to sit with the canola based on the inoculum levels we saw. The other thing is we looked at the patch as well and did a patch assessment, and again you can see the canola plots had significantly lower levels of patches than in the barley plots. So it does have an impact on your disease. And while I'm here, I want to point out that cultivation is something that still works. We did have a cultivation treatment in that particular trial, and this is just showing you the two plots side by side. First is no cultivation below the seed, whereas this one is a 10 centimetre cultivation below the seed at the time of sowing. Moving on to the new fungicides. So this component was funded by Bayer and Syngenta and GRDC, and with that we have got now registration for this year's use of Evergold Prime and Uniform in farrow. Now Evergold Prime obviously is also registered as a seed treatment, and now this year it's also registered for use in farrow. Uniform on the other hand is only registered in farrow, but you can use it in farrow but also in split application above and below the ground. And both products also can be applied on a granular fertiliser and put into the ground that way. Just to show you what this looks like in the field, so the in farrow application in with the liquid nitrogen, ends up in this zone, and it protects the primary roots. And obviously, yes, you can also do the same thing with a granular coated fertiliser and get the same efficacy as you would with liquid application. Uniform is also registered, as I said, split application, so above the ground and then into below the ground. What this does, it actually protects the crown roots. So as the fungus moves down the profile and the crown roots are developing, it's protecting them. And you'll see what that impact has on yield. This slide just shows you the effect of untreated and treated for Evergold Prime. In this case, we put it on the seed and also in furrow, and this is definitely on the registration. The most important part of what you probably want to see is what effect did it have on yield. So I'll cut to the chase. What we've got here is a combined site analysis. So it includes for all treatments between 2 to 6 trials from WA and South Australia, so it's combined together. And it's the net yield gain over the nil plots, okay? So that's why there is no nil at the bottom. We've got the 2 seed treatments. You've got a registration for low and high. The 80 mil is actually significantly different in the meta-analysis, or the combined site analysis. And then you've got combinations with seed and then all in furrows. And again, this 80 mil in furrow is again significantly different in the combined site analysis. Just to put some figures, thank you. Put some figures to those significant ones in the combined site analysis. So for the seed treatment, it's $33 net profit. And for the in-furrow, it's $52. This is using these assumed figures, and we know Evergold Prime costs $145 a litre. Now I want to just show you some data with uniform, again showing you the plot treatments, untreated with treated. In this particular case, it's the split application at a total 300 mils. Above and below the ground. Just to show you now the yield data, in this particular program we had up to, I think, 15 trials for each treatment, and we also had wheat and barley, okay, that we trialled. The ones with the stars are the ones that are again significant in the combined site analysis, which includes the WA and South Australia trials. In this particular case, obviously the seed treatment is the Vibrance, and Vibrance goes in at 360 mils, so no different rates there. And then we've done a combination with in-furrow, which is the uniform. 2 different registrations, 300 and 400 mils, and then you've got the in-furrow plus surface, which is the split application. At 300, so this one compares to this 300, and then the 200 compares to that. What you can see is the split application certainly performs a lot better because you're getting that protection of the crown roots as well. The other thing to note is the barley responds a lot better than the wheat, and you can see that quite clearly, especially for these treatments at this end. Again, I want to put some figures on the treatments, the in-furrow treatments. You're getting a net profit of between 48 to 122. So quite good. And uniform is $63. And again, I'm assuming that the barley return is that. I've only put barley up in this case because barley is performing better, but we could do the same calculations for wheat. This is my second last slide, just to say while we've wrapped up the fungicide research, we are now moving on to the next phase. We have a new GRDC project at DAFWA where we're looking at mapping Rhizoctonia patches using UAV, and hopefully that could be at some point utilised to do variable rate technologies and other diagnostics as well. So that's where we're moving, and I just want to point that out, and I'm sure next year or the year after we will be presenting some information on this. My final slide, the 3 key messages. Yes, you can rotate with canola to reduce Rhizoctonia inoculum and also disease levels. And then we now have in our toolbox the new in-furrow fungicides, and they do offer really good control. But you'd have to remember it's not the silver bullet, so you need to include that as an integrated management package as part of that, and not solely on its own. And then a goodie and an oldie, yes, you can still cultivate at 10 centimetre below the seed to break up the inoculum and also offer the root a quick passage down to avoid the infection with disease. And with that, I move on to Trevor.
Thank you, Daniel. Thank you all for attending this session this evening. Going to start off with a bit of a disclaimer. As mentioned, I'm from the commercial section. We've got many people in R&D, but they all find themselves at a conference in Sydney this week, so you've got me. It's always fairly challenging presenting to a room when you're pretty sure that everybody in the room knows more about a subject than you do. I'm going to move straight on. I'm not going to concentrate on Rhizoctonia because Daniel did a very good job on that, other than highlighting that Uniform is the only product currently registered for the control of Rhizoctonia and Pythium in Australian wheat and barley. Everything else is only registered for suppression, and that step up from suppression to control is notable. What is Uniform? As stated, it's the new in-furrow fungicide from Syngenta and provides the only control claim of Rhizoctonia, also providing control of Pythium, also known as the common cold of wheat and barley, both which add to the yield benefits attributed to this product. Uniform also provides control of stripe rust up to 100 days and also has benefits on yellow leaf spot and other diseases. In a number of cases, we are going to be advocating Uniform and Vibrance be used in combination. There's a number of reasons for this. Uniform controlling the Rhizoctonia, Pythium, and stripe rust. Vibrance gives you the smuts, bunts, and the seed-borne net blotch. Also, Vibrance will give you the early Rhizoctonia control. Obviously, you're not going to get control from the in-furrow product until the roots have got down to that band. So Vibrance does give you that early control. Just some of this is repeating Daniel's work. You have the 2 options being a split application with the liquid or an in-furrow application either with a liquid or with a fertilizer. When applying Uniform as a liquid, please use a minimum separation of 15 mils from the seed. And when applying with fertilizer, use the minimum distance recommended for the fert. Just going quickly through the folio slides. Sorry, this is going quick, but we are running out of time. Stripe rust, percentage reduction. You can see at less than 100 days after seeding, we're getting excellent control with 200 and 300 mils of Uniform, and with the control dropping off as we go past 100, 110 days after seeding. Yellow spot, you can see a significant rate response curve there, moving from 200 up to 400 mils per hectare. You can see a comparison there with intake in furrow. I understand intake's not registered, but as you can see, giving no control at all in comparison to the Uniform. Just some more yield and return on investment figures from a number of sites over South Australia and Western Australia. Just to get your eye in, the height of the bar relates to the left-hand column, which is the yield advantage in kgs per hectare. The triangle relates to the right-hand column, which is return on investment after cost of application and treatment is taken into account. As you can see over the various application types, we're getting very, very strong return on investments. I see they've only used a price of $200 a tonne for the barley in this. It looks much more impressive at Daniel's 320. I'll have to work with the marketing department on that one. Of interest here to pick up is that these trials and these results come from a variety of yields, from 1.2 to 4.2 tonnes per hectare, showing that you get significant return on investment above cost of treatment from all ranges of yield potential. It's not pigeonholing into the high yield areas. It is valuable and viable across all yield types. Just some commercial work. It is commercially available at present. It is being sold under agency to help facilitate stewardship in the key area of fungicide resistant management. It is available in tens, hundreds and thousands primarily going to the fertilizer companies. If you've got a grower who really wants 1,000, I'm sure I can make a plan for you. When it's treated on fertilizer and supplied through an authorised fertilizer service provider, it will be sold as per volume applied to the fertilizer order. We have an update from CSPP and Summit. Both companies are willing, able and ready to treat. CSPP will be doing their first treatment date on March the 18th and then will be treating as necessary. Summit are available to treat as and when required as per orders. Some cost per hectare, moving from the 200 mil per hectare rate at $12.66 all the way through to the 400 mil at $25.32. In summary, this product has been developed collaboratively by Syngenta and industry partners, and I'd like to thank DAFWA and SARDI for all their great work on this. It controls key diseases identified by Australian cereal growers. We've obviously worked on the diseases that growers have come to us and told us are most significant. There are a number of other diseases we are working on, and I would expect to see significant label extensions as time goes by. These replicated independent trials have demonstrated significant yield advantages, and we advocate in many cases for uniform in-furrow and vibrant seed treatment to be used together to give the broadest spectrum of results. That would be the end of that.